to you, Craig.
Thanks a lot. So I'll put everyone at ease. This will in fact be one of those free-ranging, rambling talks, because I've just started working on this stuff, and both this work and this talk are embryonic. What you see on the screen, which hopefully you can read, involves a lot of fancy ingredients, but I assure you it's not very polished at the moment. So yeah, first I just want to get some sort of confirmation that you can actually read what's on the screen, because this is a 4K monitor and it might be too tiny. Since everything you're looking at is in a web browser, I can zoom it up and down pretty easily. So just let me know if something's not legible. But in the last few years, it seems like everyone has gone high res, so it should be all right. Tim, can you read what's on the screen?
It's kind of at the limit for me, so it's small, but I can read it. You might have to read a few things out, but I think I get a sense of where you're up to. I mean, if you go one notch higher, it might be a little bit easier, but then it gets difficult to present, I suppose. So what do you think?
Yeah,
maybe that's a bit better.
Yeah, it just means moving a few windows around. That should be fine. So yeah, I've done some work in exploring WebAssembly as a Smalltalk compilation target. WebAssembly has come out in all of the major web browsers in the last few years as a way of deploying portable high-performance code that web apps can use that is written in one of many different languages. And that's my main interest in WebAssembly, is that it enables a polyglot future for web app development, where we're not so tied just to one language, JavaScript, as we have been in the past, but that we'll be able to bring code bases from all sorts of different languages to bear in web apps, including our favorite one, Smalltalk. And yeah, so I guess my original motivation was, what tools can I have in my arsenal that will let me do dynamic code development, everywhere where I want to do it without going crazy. And I kind of, held off getting into web development for quite a while because the development stack, involved in writing for it for many years just seemed, wildly overcomplicated, and also kind of static with all these build steps, like, as with other platforms I'd used before. But at one point I, realized that what people were doing in the dev tools in web browsers was using JavaScript in quite a dynamic way. And then, the deal was sort of sealed when Vanessa Freudenberg released Squeak.js, a JavaScript implementation of the Squeak Smalltalk virtual machine, and got decent performance, running normal Squeak object memories in a web browser. So then I thought, oh, wow, I really need to dive into this. It was pretty cool to see that all of the APIs for things that you can do in a web browser can be, live coded as well. For example, these slides that I'm using, this is just a little HTML div that I created in Squeak.js, which is running on the left side of the screen. And then in that div, I put a quite nice slides framework that someone happened to write in JavaScript called Impress, which sort of was inspired by Prezi, a very dynamic, or visually dynamic slide presentation framework. So you can do things like have your slides arranged in various 3D locations and sizes. So when you move from slide to slide, you can have these nice transitions like this one. Hopefully the frame rate that we're getting on this screen share is high enough that you can see that animating. You get a lot of things, a lot of nice things for free when you're just running in a web browser, as opposed to just statically generating code for it. So WebAssembly is another framework like that. Just like this slide presentation framework, you can live code it, from within your running web app. So yeah, with Squeak.js and then later this Caffeine framework for interfacing with web APIs, I've been just trying to do mashups of Smalltalk with every interesting web API I can find, and WebAssembly, sort of the latest one. So all of that meta context brings me to my first actual slide, which is just saying, as I said before, that all of the stuff I've been doing with WebAssembly, I just barely started it. But you can read, updates about what I'm doing at thiscontext.com, my blog. So the roadmap I have for using WebAssembly with Smalltalk kind of goes like this. First, I just want to be able to establish any sort of connectivity with WebAssembly, in a live way. So the first experiment, which is what I'll be showing mostly after this slide, is just something I call Hello WASM instead of Hello World. And that follows from an example given at the excellent Mozilla Development Network site, which hopefully you can see on the right side of my screen. For Hello WASM, I just want to show creating a global variable in WebAssembly, giving it an initial value from WebAssembly, reading it from JavaScript, and therefore also reading it from Smalltalk, since when you're running Squeak.js, you can make Smalltalk objects which are also JavaScript objects. And then setting that global variable, to another value from Smalltalk, and being able to read that new value from WebAssembly, then sort of doing the converse, having WebAssembly change that global variable and then reading it from Smalltalk.
Cool.
So so I have the Mozilla Development Network example of a WebAssembly global variable, done in the normal HTML web page way here. And that works. So I want to be able to use the JavaScript bridge that's in Squeak.js to be able to do the same thing from Smalltalk. And I'll talk even more about Hello WASM in the next slide. But just getting back to the roadmap, that's the first thing I want to be able to do. just sort of the most trivial example of showing connectivity between all three of Smalltalk, JavaScript, and WebAssembly, focused on one global variable. After I do that, then I want to be able to write the very simplest virtual machine plugin for the Open Smalltalk VM, and show that working, just showing that I can integrate WASM as a runtime into the normal way of writing Open Smalltalk virtual machine plugins. So along the way, I imagine I will come up with an analog to the slang technology behind that, which lets you translate Smalltalk to something that your target runtime can deal with. Up until this point, Slang has only supported C and JavaScript. I'm hoping to add WebAssembly to that. So I want to be able to have the ability to have a Smalltalk class, which is, perhaps constrained as to what you can actually say in Smalltalk, like classic Slang is. But, if you work within those constraints, you'll be able to translate a Smalltalk class to a WebAssembly module source code, generate that source code, and then instantiate that source code in WebAssembly as part of the running web page in which you are running Squeak.js, and then interact with the WebAssembly module that gets created when you do that. Okay, so that will all be for some minimal virtual machine plugin, which probably will do nothing more elaborate than getting and setting a global variable, just like Hello WASM did. But once I've got that, then I want to take a very large leap up in complexity by making a virtual machine plugin that has behavior equivalent to the current BitBlit virtual machine plugin, which is what's making all of these graphics here for Squeak.js. There's a JavaScript version of the BitBlit virtual machine plugin that's been translated. So it's been translated to JavaScript instead of C, and on the fly it is blitting to an HTML canvas, so that we can see this Open Smalltalk user interface. So that'll probably be the hardest part of this entire roadmap. And I think once I've got that going, just for the preparations I've made for this part of the roadmap so far, I think I'll be able to make an actual object memory that lives inside a WebAssembly module's memory. So the next thing I'm going to try after writing that BitBlit virtual machine plugin is actually implementing the entire stack interpreter of Open Smalltalk and just get it to run something simple like 3+4. Then once it's done that, I'll try to make an entire usable system like what I'm running now in Squeak.js. And assuming I get that far, then the next thing to try would be actually making a cog virtual machine this way, running the Sista instruction set, both of which are quite nice. At the moment, I'm kind of expecting that I'll run into limitations of WebAssembly that will prevent me from running a kitchen sink image that's everything I want it to be. At the moment, a WebAssembly module can only have one memory, and it's not that huge. But we'll see. I think we'll be able to do interesting things with this stuff. So yeah, sorry, it's often happens in a young talk. That's a ton of information to have put onto one slide. So I just want to stop and answer some questions if there are any.
Yeah, Craig, I've got a question.
Mm-hmm.
Are you aiming at mobile, and are there any papers, studies, evidence about the power consumption of different languages you could run on platforms, you know, from C, Swift, JavaScript, WebAssembly, all of those things?
My goal is to, yeah, well, WebAssembly runs on mobile quite nicely, so I will be going there. And in fact, there's another talk I'd like to do that just shows the affordances I've built for running Squeak.js comfortably on phones and tablets. But I have not done serious comparisons in performance between WebAssembly and Swift and all the others, for example, on mobile. And frankly, today, I'm not expecting WebAssembly to do all that well. All I've really been paying attention to so far is the performance of WebAssembly versus JavaScript in web browsers. Yeah.
Sorry, when you say performance, do you mean power or speed? Because I'm worried about power at the moment.
Both. Yeah, certainly both.
Okay, thanks.
Yeah, one of my main use cases is being able to, hack this stuff live on a device that's in my pocket, at a cafe or whatever, and to be able to do that all day. So I'm, very concerned about that. And also very concerned about not tying myself to any particular web browser. For example, I want to make sure that everything I'm doing doesn't become Chrome bound and runs equally well on Safari, because so far mobile Safari has been a lot better with energy use than other experiences I've had on Android devices.
And you'll pick up Android too by using WebAssembly, whereas Swift, I don't know how well it's supported on non-Apple platforms.
To my knowledge, it isn't. And like I say, until WebAssembly can soundly beat JavaScript in both energy performance and speed performance, then I'm going to wait until that happens to really do a broader comparison.
Sounds good. I was just wondering about the roadmap and the assumptions behind it.
Yeah.
Greg,
yeah.
In the early kind of like midway through your roadmap, so is the idea that you kind of have a Squeak.js VM running some of your code, and maybe bits of it are kind of running in WASM, and there's that kind of interop between them, and then bit by bit you see if you can slowly get it to the point where it's all in WASM? So is that like an image that is running with a VM in WASM? I'm just trying to understand the final point, or is there always going to be both? Do you think is that kind of the thought process?
Well, I'm hoping to incrementally migrate individual functions of the Squeak.js VM from JavaScript to WebAssembly. It's a bit like the just-in-time compiler that Vanessa wrote that translates Smalltalk compiled methods, so Smalltalk instructions, to very optimizable JavaScript, something that V8 can generate very good native code for. So I want to be able to, on a Smalltalk method basis, generate good WebAssembly for each method, and I want to make the Squeak.js VM itself a bit more reflective in its implementation, so that more and more of its JavaScript functions actually came from Smalltalk compiled methods also.
Okay.
If that makes any sense. So like right now, the Squeak.js VM has a ton of very nice handwritten JavaScript in it. And I just want to try to migrate as much of that as I can to Smalltalk. And yeah, it's definitely a bootstrapping process. I'll be using the handwritten Squeak.js VM, all along the way. And I kind of doubt there'll ever be a point where I have 100%, replaced everything in there with WebAssembly that I can generate from that running system. But I think as close as I can get to that will be, very useful in the intelligibility of the system. How easy it is to understand it just from the Smalltalk level. Even though there are quite nice tools in Squeak.js for inspecting the JavaScript layer beneath you from Smalltalk. I just want to minimize the amount that you have to use that stuff.
Cool. I think at this point we're probably asking the questions that we should be asking at the end. I sort of realized that.
That's great though, because this is the very first version of this talk, and there are only 3 slides, and it should mostly be questions and answers as we go. Yeah.
All right. Question.
Yeah.
Greg, let's see. If I'm not mistaken, all right, the normal Smalltalk converts to bytecode, and then the virtual machine runs the bytecode, correct?
Mm-hmm.
How is Squeak.js different?
It has a JIT there, which when you run a method, it translates the Smalltalk bytecodes to JavaScript and installs that in a method cache.
I see.
And then when you run that JavaScript, your JavaScript runtime, V8 or whatever, underneath you will generate native code for that JavaScript and cache, and has its own native code cache for that.
Okay.
Yeah.
So, okay. So right now, the goal of the WASM virtual machine is to convert the Smalltalk bytecode to WASM.
Yeah. Sorry?
So you will have a WASM virtual machine converting the Smalltalk bytecode into WASM. Is that correct?
Right.
Okay.
Subject to constraints about what you can do in those Smalltalk methods. I'm expecting that there will be some things that you just do not translate. Just like in current slang, there are some things that you cannot say in a method that you're going to translate to C or to JavaScript. So that's why I say the target is simplified JavaScript or simplified C. And likewise, I think it will be
so
yeah, a constrained subset of WebAssembly. Sorry?
So at the point where you cannot translate, then you run that interpretively?
So in the case of the stuff I'm doing with WebAssembly, yeah, there will be some things where you'll just have to settle for having your Smalltalk compiled method translated to JavaScript, and from that to native code. And there'll be no other code path through WebAssembly for that Smalltalk compiled method.
Okay.
Right. But for things, at least for the use cases I'm starting with, like BitBlit, that's not going to be a problem. I'm pretty sure that code path will work in WebAssembly.
Right.
I think the main thing that has to get finalized in the WebAssembly spec before I can say that with certainty is the JavaScript API for interacting with WebAssembly. There's an initial version of that is deployed now in all the popular web browsers, but it's not finalized. In particular, what is the JavaScript interface for interacting with the WebAssembly garbage collector? The WebAssembly garbage collector itself has not been finally specified, so there are a bunch of things sort of up in the air there. But
now,
just like Squeak.js uses the JavaScript runtime garbage collector to great effect, I think any serious stack interpreter or COG implementation using WebAssembly will use the WebAssembly garbage collector to great effect also.
Right. So WebAssembly is sort of work in progress. How much more progress is required in WebAssembly to really be Turing complete or JavaScript complete?
Oh, no, it is now. The basic execution spec is pretty solid and has been deployed for a couple of years now in web browsers. It's just the garbage collection execution machinery and the JavaScript interface to it that everyone is waiting excitedly for, especially dynamic language implementers.
All right. Thanks for doing this. Hopefully, Smalltalk will be on the web technology. There's no more excuses.
So. Oh yeah. I felt that way about Smalltalk on the web, ever since Squeak.js came out, and being able to show Squeak.js running Squeak and Pharo and Cuis, and having them all talk to each other within one web page, or within one web browser, has been really exciting. I think ultimately WebAssembly will be a useful way of speeding up some parts of the system, like Bitblet, or making plugins to do various exotic high performance things that you want to bolt on to the basic system. But right now, the performance of Squeak.js just running a kitchen sink Squeak object memory is quite useful, and this is all using Bitblet onto an HTML canvas. There are other experiments I've done where you're running Squeak, but you're using completely HTML graphics to see what you're doing. In particular, using web components. So you're not using Bitblet at all, and in fact, Smalltalk is mostly sitting around waiting for you to ask it to do things. There's a surplus of performance there.
Okay.
So I think the performance and also energy use future for this stuff is very bright.
Okay, last question. What does WASM bring over JavaScript? Just, how does WASM benefit Smalltalk over JavaScript?
Well, the main thing I think it does is it enables this polyglot feature that I mentioned before, a playing field in web browsers where there is no preferred language. You can use any language you want, and you can mix languages together to build what you need. So I'm hoping we'll get to a place where, just like to a large degree on the so-called native platforms, you can mix code from different languages and nobody cares as long as it does what the contract you've set up says it should do. I think that'll be really nice to get beyond having a single preferred language that we've had with JavaScript.
Okay.
And then, ultimately WebAssembly will, I think, bring some speed improvements, and that's sort of how it was initially pitched, but it's not there yet. It's only slightly faster than JavaScript on intense numeric stuff, and only some of the time. There are other things where WebAssembly is actually slower than V8, for example, the V8 JavaScript performance.
Right. Okay, I'm done. Thanks.
Yeah, sure. Thank you.
You want to show your hello? Do you want to show your hello WASM?
Yeah. So going on to the last slide. So I've started doing hello WASM, and yeah. So that's just reading and writing a WebAssembly global variable from Smalltalk, JavaScript, and WebAssembly. And when we're dealing with Squeak.js, sorry, can you see my mouse when I'm moving it around?
Yeah, we can. Yeah.
Yeah. Okay. Good. So I can point at things. At the Squeak.js side, Smalltalk and JavaScript are really, equivalent, because Smalltalk is running as a JavaScript implemented virtual machine, and any JavaScript object you make in this web page that's running the system can be seen and manipulated from Smalltalk. And any Smalltalk object you make can be seen and manipulated from JavaScript, for example, in the Chrome DevTools. So that's just something to keep in mind. It's not like there are more than 4 interactions to deal with, because there are really only 2 players, Smalltalk / JavaScript and WebAssembly. So to show you what I mean, we can look at this JavaScript-based example of getting and setting a WebAssembly global that was on the MDN site. Here is the web page, the HTML where this stuff lives. First, we make a JavaScript function for just doing assertions and reporting on success or failure. Then we see that the part of the WebAssembly API that lets you create a WebAssembly global is actually in the system. And if it is, or assuming it is, we go on and actually create a WebAssembly global variable. We give it a type. We say that we can modify it, and we give it an initial value of 0. Then we actually instantiate a WebAssembly module from a WebAssembly source file. And I'll take a little diversion here to show you that WebAssembly file. This is a WebAssembly module written in a format called WebAssembly text. And it's kind of Lispy, which I like. And it lets us import the WebAssembly global variable that we created in JavaScript. And then it defines 2 functions, one for getting the value of that global variable and one for setting it. And this one that sets it is actually a little bit fancy. It gets that global variable, and then it adds 1 to it, and then sets that new value back to the global variable. And you'll notice that WebAssembly is well, I guess you can probably guess from the code, but you really know from reading the WebAssembly specification that WebAssembly is manipulating a stack-based machine. So when you actually run an instruction like global get, you're getting the value of this global variable and you're pushing it onto a stack. So that's what this instruction does. Then this instruction is pushing the constant 32-bit value for 1 onto the stack. And then we're running the instruction add. So we're adding together. And after we've done that, then the result of that will be on the top of the stack. And then this instruction sets this global variable with the value that was left on the top of the stack by add. So it's very useful, very interesting that this is a stack-based virtual machine. This is what got me thinking, oh, can I translate the stack-based Smalltalk instructions, Smalltalk bytecodes, to these WebAssembly instructions, and enable some nice slang-like experience for supporting WebAssembly from Smalltalk in a web browser. So anyway, if we've instantiated that WebAssembly module, then the fun part happens. We can, from this WebAssembly module instance we've made, we can actually run a function that it has exported, this get global function. That was exported here in this WebAssembly definition. Oops. So we want to get that global variable and assert that its value is in fact 0, just like as we created it. Then from JavaScript, we're going to set the value of that global variable to something else. And then once again, run the WebAssembly module's get global function, and this time assert that the value of the global variable is this new value that we've given it. Then from JavaScript, we're running this increment global function that our WebAssembly module has exported, so that it will increment the value of the global variable from 42 to 43. And then we check that we can read that new value that WebAssembly updated, and we can read it from JavaScript. So yeah, hopefully that makes sense. Let me know if you're confused by that. Let me know, because what I'm going to be talking about, from here on out is how do we generate this WebAssembly stuff from some equivalent Smalltalk, and then actually instantiate it and use it from Smalltalk also.
Question, Craig.
Yeah.
Hey, how are you doing? Always doing fascinating stuff, I see. Regarding to this, no marshalling between WASM and the JavaScript side, that 43 or that 42 that goes back and forth doesn't happen. It is the same type. There is no transformations, or it's done for you.
It's done for you by the WebAssembly runtime.
So we expect no penalty for that.
That's right.
Cool. That's good.
the JavaScript interface to that WebAssembly runtime is hiding all that from you, and it's it performs quite well. I mean, obviously, you can't violate the type restriction that you put on your global variable, but other than that,
right.
It works nicely.
It's like you kind of you show the right thing. Yeah, the restriction is set from the JavaScript side, so WASM will assume that you're using it right, and everything will go smooth.
Yeah.
Cool.
Yeah, and like if you had not said that it was mutable, then you couldn't do this either. You wouldn't be able to do this line here where you actually change the value. Yeah.
And sorry for the ignorance. You mentioned WebAssembly has a garbage collector, so it works that way then for memory management. Okay, cool.
Yep, it will, but that part has not been released yet. It hasn't even been finalized yet.
It's very young. Yeah.
They're trying to nail down the JavaScript API for that garbage collector in a way that everybody likes before they actually deploy the garbage collector in web browsers. But there's been great progress on that recently. So unlike a couple of years ago when people were saying, "Oh yeah, give it a year," but then you would look on the GitHub discussion sections of the repos, and there would be no conversation. So it was kind of hard to trust those estimates. But now there's a ton of very productive conversation going on there, and some good draft specs for the JavaScript API to the WASM garbage collector. So now I feel like, this is actually happening. So it's pretty cool.
Nice. Okay, cool.
Yeah, okay. So over here in Smalltalk, I have a class called Hello WASM, which is a subclass of ultimately another class called JS object, which is the proxy class in Squeak.js for making Smalltalk objects that are proxies for plain old JavaScript objects. So similarly to how JavaScript over here was able to make a WebAssembly global, we can do the same thing from Smalltalk using a proxy class for WebAssembly.global I made, which in Smalltalk is just called WebAssembly global. So there's actually a JavaScript API for creating instances of another JavaScript thing called WebAssembly.module. And so here in Smalltalk, I have a corresponding class that's just called WebAssembly module. And so Hello WASM is a direct subclass of WebAssembly module. And the idea here is that this thing, an instance of Hello WASM, will be able to support both a normal Smalltalk message interface for interacting with its instance variables, and that very Smalltalk method will be translatable to the WASM function that you want to end up in the WASM code that you're going to instantiate. So
it's
yeah,
like
sorry.
it's like using a sort of slang for WASM, but you are using it live instead of just generating a thing that will be compiled afterwards.
Yeah, exactly.
You're
so
using
the
it on
whole
the spot.
thing
You create it on the fly, use it, and that's interesting. Okay.
Yeah, exactly. So it's yeah, I think it's quite neat. Yeah, I can't even really think of I mean, C just isn't as dynamic a thing at runtime as JavaScript is, so there's really no analog to it. But this, slang-ish code that you're running here is actually something that's useful at runtime in a proxying situation. And I think that will be quite useful. So the trick here now is to take the Smalltalk instructions that we have for each of our hello WASM methods and translate them into WASM instructions. And this is where epigram really comes into the picture, because it just so happens that one of the compilers that I've written with epigram already is a Smalltalk compiler, and it has some interesting features that lend itself to translating from one instruction set to another, even if the instruction set is, relatively different, like not even a Smalltalk instruction set at all. I think there will also be interesting things we can do for translating, say, Squeak instructions to VisualWorks instructions and vice versa. But yeah, right now we're just thinking, how can we take Smalltalk instructions and create equivalent WASM instructions for them, and then get those WASM instructions to write themselves out as WebAssembly text in a full-fledged WebAssembly module.
That will be, sorry, because I'm trying to understand the applicability of that. Is for running things made on the spot, or for like also if you want to do it manually or manual written code to make it easy to integrate or with the automatic...
Yeah, all of those things. I imagine it being useful for things that you probably will write once and debug and then just use, like Bitblit. Probably not going to want to fiddle around with how that works, dynamically much. But also for just one-off experiments where you just want to see, for example, what performance benefit do I get by making this stuff run as WASM? And I would like it to be very simple for you to just decide on a whim, I'm gonna do that profiling and then decide whether it's really worth pursuing or not. That would be a really useful application of this. So we can already tell from inspecting, the decompiled Smalltalk instructions of this increment method, and comparing that to what was in this WebAssembly text file, that they're pretty close. We can probably do this. Oh, whoops, I had a better, more direct comparisons. So here I've just copied the WebAssembly for this one function here to this window, just so they can get them right next to each other and look. And you can see, yeah, they are quite similar. So now we get to sort of where I am right now, which is in this Smalltalk debugger. I'll just iconify the slides for a second. So give a good overview of this real quick. This is the Smalltalk compiler deserves a whole other talk, but I'll just touch on a few aspects of it. What I've done is so I wrote Epigram originally to deal with yet other languages. I wanted to parse protocol buffers, if you've heard of that. And I also wanted to parse and render SVG. And those, I had good experiences with those two. And those led me to think that, wow, I could actually make a Smalltalk compiler which is more understandable. I had always been unhappy with the classic Smalltalk parser and compiler. The control flow in those things, I always just thought was extremely obscure. But now with Epigram, I have this way of writing the eBNF of a grammar as Smalltalk code, so that you can have BNF symbols, production rules, which are Smalltalk objects, and those Smalltalk objects can actually parse what they are describing, the rules that they're describing. And once they have parsed source code, you can use those production rule objects as your parse tree, as your AST. You can read more about that in one of my blog posts on Epigram. Well, it's just the first one so far. If you go to thiscontext.com, it's one of the most recent ones. And I think there's also a search function there. So one nice thing about that is, or the way this Smalltalk compiler shook out doing it this way, was the assets which are compiled by the Smalltalk compiler are actually first-class objects. So like a Smalltalk instruction is actually a Smalltalk object as well. So if I want to decompile a compiled method, and here I have my hands on the compiled method for hello WASM increment. The first thing I do is actually get the production rule for a complete Smalltalk method that has actually that corresponds to the actual instructions for that compiled method. So method declaration here, this is a production rule of Smalltalk. And in Epigram, production rules can also print themselves out nicely. So when you look at the print string for an Epigram production rule, oops, of course I always forget to do this. Sorry, my take a break thing just kicked in. Turn that off. So this is actually BNF for the production rule method declaration, but in a way which is expressed as Smalltalk code. And I guess by way of context, I'll just show some of the initialization for the Smalltalk grammar. If you've ever looked at the railroad diagrams for the Smalltalk grammar on the end pages of the Blue Book, you'll see that what it's attempting to do is show you the complete BNF for Smalltalk. So I was thinking, wow, if we can have this railroad diagram, then we can also express this as Smalltalk code. So for example, what's a good one? A comment is a double quote character followed by a comment character. This is another rule. Repeated, followed by another comment character. So for the different parts of BNF, I have just a simple Smalltalk message, interface. So instead of saying, open another workspace here. So instead of saying comment character star, which is what you might see in BNF, I say, I use the Smalltalk syntax, comment character repeated. And that just means, something repeated 0 or more times. And, similarly, in BNF, you can use a question mark to show something that is optional, something that happens 0 or 1 times. And in epigram, in epigram, you would just say comment character option. So that just gives you a flavor. I mean, I've already gone halfway through BNF. I won't talk about all of it, but BNF is pretty simple. So anyway, there are, and then, well, I'll do one more. In BNF, if you want to say one thing followed by another, you would say one thing, space, another thing. Whereas in epigram, you say one thing, double bar, another thing. So in this way, I've come up with a Smalltalk syntax for saying things in BNF. And so I've actually used that syntax to write down all of the production rules for the Smalltalk grammar. And here I have to shout out to Alan Lovejoy. He, for another project, actually figured out what is the complete BNF for the Smalltalk grammar. The railroad diagrams in the Blue Book are a great start, but they actually have some mistakes in them and are far from complete. But Alan Lovejoy, figured out what actually is the entire BNF for Smalltalk. And even what he did had a few mistakes in it, because I don't think he ever wrote a Smalltalk compiler with it. But now I have, and actually worked out all the kinks in it, so that you can actually, parse any method you're likely to encounter in Smalltalk. So, sorry, this is a lot of background, but this is just an inspector on an actual epigram production rule object, the one for comment. And here we see that double quote that it starts off with. And then this is the comment character rule printing itself out. There are a lot of possible characters you can use in a comment. And then followed by that last double quote. I just want to stop here if there are any questions about epigram itself.
Is epigram available somewhere?
Yeah, epigram and the Smalltalk compiler are in the latest release of Caffeine, which is at caffeine.js.org. And this thing that I'm running here on the left is Caffeine as a so-called single page application, or an SPA in web speak. So if you go to caffeine.js.org and you click on the /SPA entry point, then it will, oh, sorry, it was spending some time waiting for a content delivery network that supplies one of the JS libraries I use. But anyway, it'll fire up this SPA version of Caffeine. And that's running the latest Caffeine image. The latest Caffeine image is just sort of a snapshot in time of what I'm working on. It's a mess. It's not, I would call it alpha right now. But it does run.
Good question, Greg. The Smalltalk grammar, you're using it, what's the applicability that you are using it in Caffeine? I wonder, is to generate the JS or make it running?
Oh yeah, so my original motivation was, sorry?
No, I'm trying to understand the applicability of having the Smalltalk compiler that you made.
Oh yeah, well, I mean, my original motivation was just to have a more understandable Smalltalk compiler than the classic Smalltalk 81. I intend to use this. I intend to recompile the whole system with this compiler and use it exclusively and throw the old one away. In particular, because I think the way it does decompilation is a lot easier to understand and a lot more powerful, because Smalltalk instructions are actually reified as first-class objects.
Got it. Perfect. I got your.
Yeah.
Because it's also a lot of effort, and I wasn't understanding what moved you to make it.
Yeah. Yeah, those are my motivations, and it's just a nice coincidence that this WebAssembly work is kind of obviously enabled by that, but I had no idea that was going to be the case when I started.
Yeah, good design has that effect. Brilliant.
Yeah. So it's one of these cases where it sort of started off with a crazy idea, and I just want to keep pushing it to see at what point does the craziness make the whole thing fall over. But I don't. So far, it hasn't. So yeah, I'm pretty encouraged by that. And there's support for both the classic Squeak stack interpreter instructions and also the Sista instruction set. Yeah, and you can imagine having the VisualWorks instruction set here as another thing. And so what I'm doing right now is coming up with a Smalltalk version of the WebAssembly instruction set, which knows how to play nice with Smalltalk instruction sets when you're doing decompilation. And that's what this debugger is, heading toward here.
By making everything be first-class objects. The design became more flexible to be extended properly without mixing concerns. So I can see that.
Yeah. And indeed, the whole notion of decompilation now can transcend whatever language you happen to be working in at the time. Whereas in the classic Smalltalk 80 way of doing compilation, there's a whole bunch of stuff that's hardwired about how decompilation works that's specific to not just Smalltalk, but a particular Smalltalk construction set. Yeah. So, right, so here I've got this Smalltalk method declaration object that corresponds to this increment method in hello WASM. And if we explore it, we can see its outermost rule is method declaration. And we can see the symbols that rule has acquired. They were created by inspecting the Smalltalk constructions that it was given. This is sort of backwards from how you would normally get a Smalltalk method declaration. You would do it by compiling human readable source code. And through parsing, you would get these constituent symbols. But I just wanted to sort of paw through what these symbols are in hopes that some of it will look familiar to those of you who have like looked around at the guts of the compiler, of the Smalltalk compiler while it's compiling something. So one of the constituent production rules of the Smalltalk method declaration, of the method declaration production rule, is another rule called executable code. And it has a bunch of constituent symbols. Local variable declarations and statements. So if we go back up to Smalltalk grammar, or actually a faster way of finding this is just looking at the shared variables for the production rules. So if I want to look for where the statements rule was initialized, I could just look for references for that shared variable, because every production rule is a shared variable that is used by the grammar and also by the tools.
Oh, and that makes navigating so much easier, doesn't it?
Yeah, see, I can just, like in this inspector, I can just type statements and print it and see what the BNF for it is. So that's really nice. Yeah, there are a bunch of really nice features of Epigram that are in this blog post. You can use the production rules as search terms when you're trying to search through the AST of a compiled method, just to get your hands on that particular part of the tree. Yeah, having all of these things as first-class objects is really nice. But anyway, I just wanted to show you, here's where we actually, initialize this stuff. For anything you see in these symbols here in inspector, in an inspector, it's very easy to get back to the actual Smalltalk code which initialized the thing. So if we go to statements, then you see there are some non-final statements. A final statement.
So have you got as far as generating the WASM code then from this?
No. I'm still here in this debugger, which is where that is going.
Right. Okay.
So this is sort of where I am now, and I've already realized very recently that there's still something missing in my in the decompilation support that my instruction set objects have. So you
haven't been able to create the full tree to then go and visit it to then generate the WASM.
Oh, I have the full tree as Smalltalk instructions, but those Smalltalk instructions yet are not smart enough to know how to create WASM instructions from themselves. If that makes sense. Yeah, what I'm showing you here in this inspector is that, yes, I actually do have the complete tree of Smalltalk instruction objects.
Right, okay.
But they don't know yet how to, well,
like what you need to,
I can see from this debugger, they don't even know how to decompile themselves into human readable Smalltalk source code yet, much less anything else.
Right.
Yeah. In particular,
ultimately, you've got to visit them all and then ask them to print on a WASM stream or something. Or
I think what I'm going to do is, once I can get all of these instruction objects, properly initialized for decompilation purposes, then I will just ask them wholesale to give me an equivalent tree of WASM instruction objects. And I will ask those WASM instruction objects to generate WASM source code for me.
Okay, all right. Yeah, makes sense. Yeah.
Yeah, so like I haven't even come up with the full model for the Smalltalk instruction objects that correspond to all of these things. I have all the production rule objects that represent these things. That's a whole parallel class hierarchy. Yeah. So to even initialize all these, sorry, this is getting obscure, but to even initialize all of these Smalltalk instruction objects properly for the purposes of decompilation, I have to interact with the instruction set for which this method was compiled to some degree. Because it knows, what these index numbers mean, for example. when you're when you're pushing an instance variable, for example.
So when you've got those WASM instruction objects and you can generate WASM source code, is there then a module that you can call via, is it JavaScript or the WASM API, that you then pass it that source code and it'll recreate you the piece that your page on the right is showing? Is that the idea? Is that like you can like, do you have to find all of those things and then instantiate the methods in WASM world so then you can use them, or?
Yeah, that's the thing. The goal is ultimately I'll have an instance of the Smalltalk Hello WASM class, and you will be able to send that instance of Hello WASM a special message which says generate the complete WebAssembly text for your class. Yeah. Which will be this. Write it to a file, get the web browser to instantiate it as an actual live WebAssembly module, and then use the JavaScript bridge that's underneath the whole Smalltalk system here to interact with it, using yourself, this Hello WASM object, as both a proxy to the JavaScript side and the WASM side of this WASM module. And I'll probably get better at saying that the more times I say it, but yeah, it's kind of a trippy concept.
Do you think you need to generate the file, or like, can you sort of push it directly somehow? Or, I mean, is there an advantage to having the file created, or?
That's just how the JavaScript API for WebAssembly works, at least right now. You have to be able to say something like this: WebAssembly.instantiate streaming, and then you have to give it a file.
You are able to kind of.
Or actually, actually, it doesn't have to be a file. You have to give it some bytes. Yeah.
Right.
But the bytes have to be these characters.
So there isn't that next level down that you can kind of inject to or call or something. It's kind of, yeah. They haven't thought about that, have they? It's like, who would want to do that? That's crazy.
Exactly, and they won't probably, because they just care about giving JavaScript programmers. At first, they only care about giving JavaScript programmers an API which makes sense in the way things are normally done there. And this is a very JavaScripty way of doing it.
Yeah. We have to kind of, work our way around it, but ultimately, if you had that, once you've got your Smalltalk model of WASM instructions, it's like, where do I write them to, right? That's kind of what you want to do, isn't it? You want to be able to then say, okay, right, then here you go. I'm going to push that stream back to you. But
yeah, but it's great because Squake.js has this fully functioning JavaScript bridge, which lets you do whatever you want to any JavaScript object or API that's in the web browser that's running you.
Yeah.
But one thing that you have also, Tim, Greg, is that you might have different cases where you have some very dynamic stuff to instantiate and very non-dynamic. So there is potential for catching. So if you know that something will have behavior that is written on stone, you want that cached, and if you have something very dynamic, you want it to stream it online. So you have to keep that in mind to make something flexible, comfortable to use the best fit every time.
Yeah.
Interesting.
You can also load the WebAssembly from bytes, no? So from an
int
array, and then you just have bytes, so you could not even read it like the text format.
Yeah, that's why I corrected myself. Rather than say file, you need bytes. Yeah, but the bytes that I want are these characters. Yeah.
But this is the readable format. But there's another format where you can say, okay, you just have the bytes in an array.
Oh yeah. There's the binary format as well.
Yeah.
And I'm working on that as well. Sorry, I've opened a debugger here on this web page, so things are a little slower now. But in fact, if we just look at this hierarchy.
What? So you're saying that fetch can does it need is that like an HTTP call to fetch bytes or fetch source? Is it still kind of it's pulling?
Yeah, to fetch that file. Yeah.
Whereas you'd like to push the bytes to the instantiate streaming, or you don't want instantiate streaming, you want instantiate direct or something, right? Is the
Yeah, instantiate streaming has a bunch more optional parameters you could give it, and instantiate streaming is only one way of instantiating a WebAssembly module. Yeah. But yeah, if we look at the grammar hierarchy, yeah, I've just been talking about WebAssembly text here so far, but I am also doing the grammar for WebAssembly binary. Yeah, and then in the past I did the grammars for Smalltalk and for SVG, and to do SVG you also have to have done XML.
Oh God, which is still alive. Yeah,
humongous. Although, of course, I cheated. I only did enough of XML to make SVG work. XML is humongous. But yeah, that's a good point. You can just give it, maybe save yourself a tiny bit of time by just giving it the WASM binary bytes yourself.
But where does it get that global.wasm from? Like, is it asking for that?
Oh, here in this fetch, it means fetch me the file called global.wasm from the same origin as this document, as global.html. So it's going to go back to the same web server that gave you global.html in the first place and give you this other file, global.wasm.
Yeah, okay.
That's what this fetch means. Yeah.
And so if you can't do it directly, how do you do you end up having to put that on a web server through so that it can then read it, or is there some cunning way to do that? Like,
oh, in this dirt simple example, they just wanted to make something really easy to understand. Yep. And the concept of just fetching another file from your web server is very easy to understand. But like we were saying before, there are a bunch of other ways of getting that data where it needs to go. Yeah.
I mean, one of the approaches would be, for instance, because let's say in Squeak.js, you have an interface. If you try, for instance, on squeakjs.org, if you try the mini image, then Vanessa has a few examples where you can, for instance, call JavaScript from within Smalltalk, or you can even have a callback into Smalltalk. And one of the approaches could be, okay, you generate the binary format or even text format, and then you use this kind of foreign interface to call the JavaScript to load it dynamically. So you do not have to fetch a file somewhere from the server, but you can grab the bytes, for instance, out of your Smalltalk side.
Right. Okay. Yeah.
Yeah.
So that's kind of in this next step. This is the bit that you're tantalizingly close to, Craig, it seems.
Yeah, exactly. Well, yeah, I apologize. I mean, in November, when I thought, yeah, I'm going to force myself to do this talk, even though I haven't written any of this stuff yet. And my goal was today show you BitBlit running, but I have just been so busy with other work that I'm only still on step 1 of my roadmap. But there were like 100 other steps to get there. So every new accomplishment is really cool because it means all the ones that came before are working.
Maybe you can open the URL that I just posted to the chat, because it shows nicely how WebAssembly can be, or what you can do with it. Basically, this is a so-called Wasm Fiddle. It's not using Smalltalk, but it's using C. But it's a simple example already when you can understand how it works. Maybe Greg can show this page or call it on a tab.
So are you talking about the Zoom chat?
Yes, in the Zoom chat.
Oh, this fiddle?
Yes, this fiddle one.
Yeah.
If you might open it. Because it's really a simple example of a C function that just returns 42. So on the left, you see there is a main function, and it returns just 42, nothing more. So this is basically when you write it and transpile it, for instance, from C. And when you click on build, then it compiles this code into WebAssembly. And what you see at the bottom is the same text format that Craig described, that he now generates as the text format that you could have. And you could use the JavaScript here at the top to load it, or you can just click on the run button, then it just runs and it just outputs 42 for the moment. But you can also have, if you use the selection box at the left, then you can also switch to the code buffer, and then you see the other way. That means this is the int byte array that you have, where you see the compilation from the text format into the real byte format. And this is also one benefit of WebAssembly, because normal JavaScript code you could read it. So you could easily reverse engineer it. But if you have a transpiled module of WebAssembly, it's hard to reconstruct the source code, the original source code.
So how is that build?
Sorry, at this point, so at this point, I'm just more interested in the text format, because I imagine I'm going to be like diddling with this, manually for various purposes as I do my experiments. Sorry, your question about the build?
Yeah, how does that build work then? Because that's effectively what you're doing there. So they're building C to that WASM format or whatever it is. So how is this JS Fiddle doing that?
There are a lot of transpilers. There is emscript and other which can compile from nearly any language today, where you can compile into WebAssembly.
Yeah.
So there's a whole tool chain available on the web that you can use.
Oh, so you pass it something called some endpoint, and it returns the equivalent.
Yeah.
Gotcha.
So you could experiment and write, for instance, in this example here, so there's a workspace where you could write C, could write, and if you say, okay, there's something I need more speedy, more faster to execute, then let's say you might write a function in C, transpile it into WebAssembly, and then use it in your JavaScript or React.js or whatever AngularJS application, and so on. But there are a lot of tool chains available nowadays where you can transpile from whatever languages into WebAssembly. There's a lot of things in the web available. And having Smalltalk as a thing, let's say if you could cross compile or transpile from Smalltalk over to WebAssembly, this would be really a plus also. You could even, let's say, the question would be if you can transpile from C over to WebAssembly, the question would be, at the moment, the Squeak.js is written in JavaScript manually. So Vanessa has written really a Squeak.js VM manually by doing it in JavaScript. But when you can transpile from C, the question would be, would you get a faster Squeak.js VM if you would use the original C files, for instance, from Squeak VM, maybe by adopting, but for sure with plugins and other, but maybe having a faster, even smaller VM on the web.
Yeah, exactly. And I'm interested in both of those things. I'm kind of attacking it from the Squeak.js starting point first, just because I have found the development experience of debugging the VM live running underneath you in a dynamic runtime that JS gives you, rather than this, doing the tricks that GDB or LLDB can do with C to be so much more pleasant. So I'm kind of wondering what path can I take to something fast without ever giving that up? Because I spent decades, debugging native Smalltalk VMs with C tools, and I've just had enough of it. So, I mean, JavaScript has a lot of warts on it, but wow, the development tools, the development experience for doing low-level stuff is actually quite nice. And I'll just throw in, okay, so I just wanted to show you, so I set a global variable for this web page, from Squeak.js, and I just wanted to show you in the dev tools that, there it is. And that gives you a hint at what you can do with this bridge. And then, while I was talking about how nice it is to have, dynamic dev tools, available to you in a web browser, just wanted to mention that another place where I've gotten caffeine to work is in a dev tools panel. So not only can you, run Smalltalk on your web page, but you can also run Smalltalk in your dev tools and debug that web page, which is also running your Smalltalk. And
That's cool.
This has been so this is a Chrome extension that was in the Chrome Web Store for quite a while, but then they changed their manifest format for extensions, and I haven't updated it yet. And they have been booting extensions out of the store that don't conform to the latest one. So as soon as I get that updated, it'll be back in the store. And I'm working on something similar for Safari, but there are some real challenges there. Luckily, well, I don't know, a year ago, it looked like Firefox was also going to adopt the Chrome extension format. So I'm still hoping that will happen. And I will only have to do 2 of these, not 3.
Yeah. It looks very cool.
Yeah, thanks. And I also just wanted to mention that the specification effort for WebAssembly is really nice. They've been very thorough about it. Sort of frustratingly slow at some points, it feels like, but the results are very well done. Yeah. Okay. Any other questions?
I don't know, but I wanted to say thanks for sharing this, Craig. It was a nice demo. It proves that there is a lot of potential in using it. Definitely, we can move in many different directions, and by showing that you can bridge the both sides in this way, every Smalltalker will have shiny eyes, because it's clear that a lot can be built with this. We have another virtual machine to conquer now. Yeah,
exactly. It's another really interesting platform, I think, for Smalltalk to develop.
Which is super universal.
Exactly.
It moves at a glacial pace, in a glacial speed, because of all the consensus that it has to grab for more, doing anything.
And I'm really looking forward to
yeah,
and I'm really looking forward to working on projects where I contribute some part of the code in Smalltalk, and a bunch of other people are using other languages. They're all mixed together and nobody cares that they're all different. That's going to be cool.
Yeah.
Looking at the chat, there are a few questions that, well, people that are here go first. I mean, and then we can go through and just make sure we've picked up on any questions that are left.
All right. What's the speed difference between a desktop app running Smalltalk and WASM running Smalltalk?
WASM is much slower at this point.
What, a factor of 5, 2?
No, I'd say it's probably a factor of 1.5, which is a lot to people now. Because I mean, ultimately, I do expect WebAssembly to get a lot faster, to be at least twice as fast as JavaScript. But you know, JavaScript, depending on what you're doing, it compares favorably with native stuff, but a lot of times it doesn't. So yeah, I'm not holding my breath for a really sexy story there, but good enough for a lot of things.
Yeah.
So it's interesting.
You're saying that native is only 50% faster?
Yeah, I wouldn't want to give like one number just across the board, but for doing web app stuff, you know, pushing rectangles around and blitting simple things and maybe doing some simple numerics. That's my rough guess.
Is that the power of V8? Is it? Is that that virtual machine that's?
Yeah, V8 is quite good.
All right, thanks.
Sebastian, did Craig answer your question about the general architecture and the plugin bit? Have you?
Yeah, it's much clearer now. Yeah, I got confused. This is what kind of what we were saying. It shows with a proof of concept that he can go back and forth comfortably. There is no FFI equivalent need here, for example. It's like you are already having the right type, because if we are not talking WebAssembly and we want to make Smalltalk and communicate with the operative system world, let's say, you have the two options of going FFI or making a plugin and making an extension of the virtual machine. But here it will be kind of the same thing. You don't have that dichotomy. You have only talking to the WebAssembly virtual machine.
Yeah. Everything just feels like it's in the same address space already.
The bit PLT, what's the name of it that you wanted to you aim as a goal to show today, but you couldn't because it was too much, the bit
I want to be able to show the BitBlit virtual machine plugin.
BitBlit, yes.
Yeah.
I'm not familiar with the internals of the BitBlit. Why it will be a plugin? It will be like to isolate that functionality there until you get the full thing, or then it will be just one thing, or it will also have plugins. How do you see that evolving? Because I understand you need to go baby steps, walking before flying. How do you see that going in the natural progression?
Well, I mean, the main motivation for it is just to have a nice way of writing BitBlit in Smalltalk that I can debug in Smalltalk and then translate to WebAssembly and immediately run. Just like now, you can translate it to JavaScript and immediately run it. That's really it. That will be the probably the end of how I tweak BitBlit for WebAssembly. I just want to show that I just know that BitBlit is a heavily used and rather complicated virtual machine plugin, and I know that if I can do that one, then I can probably do any of the virtual machine plugins. And there's also a fair amount of Smalltalk object manipulation that happens from the plugin. So if I can do all of that, then I'll feel pretty confident about doing an entire interpreter.
Okay, and the other part of the question will be: do you see the architecture of having the VM and plugins also replicating here, or on top of WASM?
As replicated?
Like the idea of having a VM, the architecture of having a VM with plugins, you also see it happening here, like a plugin for, I don't know,
oh yeah, I'm just trying to
socket, or
I'm just trying to see if I can do something that fits into the convention that we have already established in Open Smalltalk for doing VM plugins. Yeah, it might be after we have shown that yes, we can do that. There might be some even better way of structuring all of this code that we have never done for C or JavaScript yet. For Open Smalltalk.
But the idea,
I don't know what it is yet. Yeah.
Right, but the idea of plugins is present. A bunch of primitives that are aggregated by a given concern, like for example sound, or making an MP3. I don't know. All the plugins that we have.
Anything there's a web API for.
Right.
And now that, I mean, not all web browsers respect them. For the most notorious example is Safari won't let you do MIDI because it's seen as too much of a security risk. But all the other web browsers do. And there are some really interesting other ones too, like having access to USB devices and Bluetooth. So yeah, I think there's going to be a pretty healthy stable of, effectively device drivers that are available to you through web APIs.
Good. Cool.
And yeah, so hopefully they will all be equally usable on mobile devices, on tablets and things too. So my cafe scenario will be as capable as working anywhere else.
I think through that interaction, you've answered Phil's question just about the VM and implementation and JavaScript, etc. So I think you kind of covered that.
Oh yeah, thanks. Sorry, thanks for looking at the chat. I wasn't looking.
I was just kind of scrolling through.
Yeah.
I mean, Thorsten's given us a lot of links that we'll see if we can get those in the chat. One of which you put up with the web page there.
Yeah.
Someone asked about you're only allowed simple types. I think is the answer to that. It's just like all the types are just JavaScript types, and that's what you're kind of passing back and forth, right?
Yeah. But of course, I mean, if you squint, the situation is roughly analogous in the C world too, when we're implementing a virtual machine, and that's fine. I've already designed an object memory format for representing Smalltalk objects, in a simple linear memory of bytes. At the WASM level, all I need are, those simple types. And with that, I can make an object memory.
Which I then think leads to Dave Lewis's question about thinking about the scenario of a VM plugin and the plugin running in Squeak.js VM. The integration would revolve around providing access to the Smalltalk stack to the plugin. I guess is that the object memory you're talking about? If the WASM plugin can push and pop the stack, then Squeak.js can call the VM plugin in WASM. Does that sound right?
Oh, let me look. That's a long one. Let me look at.
Yeah, it might be easy.
Gonna go back and read that.
Let's see. About halfway through the chat.
Dave. Over and providing access to Smalltalk. Yep. Yeah, and that's just part of the object memory interface that I would give to WASM through the JavaScript API to WASM. If the WASM plugin can push and pop the stack, yes, it can. And Screechus can call a VM plugin WASM. Yes, that does sound right.
I think we're starting to understand this. All right, cool.
Yeah.
Oh, Dave's there. Dave's there. Did we answer your question, Dave?
Yes, thank you very much.
Yeah.
Lots of thanks going on here. I don't know, Dave, if you can mute yourself. I think you've got a lot of background noise there. Thank you. Thank you from Evelyn. How is epigram different, or in which scenarios is more suitable compared to, say, Petit Parser or SMACC? That's a good question.
It's very different. And that's kind of the thing that made me, made me think at the beginning that, wow, this is a really crazy idea. Let's just try to build some compilers with it to see where it falls down. And so far it hasn't. Yeah, it's a very different way of going about things by reifying production rules, reifying the BNF. And in fact, I will admit that epigram got started when I was working on a project where I had to write a compiler for protocol buffers to make Smalltalk components from a protocol buffer schema, where I tried to do it using both Petit Parser and SMAC at different times, and just found debugging my grammar to be too difficult with both of them. So I wanted to find a simpler way of doing things, and epigram was what came out of that.
Cool.
And I would say it's, well, I'm biased right now, just because I'm quite happy about these at least 3 successes I've had so far, that I would say it's more suitable in every scenario, because it's just so much more debuggable from the Smalltalk level. You can point at any production rule and very easily get it to describe itself. You can see where it was defined. You can make it parse things, and then from the results of that parse, you can very easily navigate your way around the AST in a way that was much easier than anything I've ever experienced with either of those parsers. The one thing I'll say is that so far I suspect that it is much slower. And I've done a bunch of work to address that. And that was motivated by the SVG compiler that I wrote. Because, inevitably that's going to get compared to the experience of loading an SVG in a web browser. It happens like that. It's instant. So any parsing you're going to do on SVG also has to be really fast. And the first 2 things that I parsed and rendered in SVG, they took seconds. So that's actually what I've been spending most of my time on the last couple of months, is just making epigram faster. Making a complete BNF grammar in epigram and parsing something with it is sort of a brute force way of doing it. For lots of production rules, you can think of very small Smalltalk methods, which will do the same thing as a particular production rule and all of its potentially hundreds of constituent production rules. So there are lots of cases, especially with XML, it turns out, where you can identify a production rule and say, oh, hey, I can do the same parsing behavior in like 2 lines of Smalltalk, where instead of like running through all the dozens of production rules that, are in the hierarchy rooted at that production rule. So anyway, just in doing SVG, I was able to, for that grammar, make epigram faster by a factor of like 100. And that's probably, I guess, the main difference between epigram and these other parsers is that the conventions involved in using it, there probably will develop a culture of doing a quick and dirty grammar, just using those expressions I showed for writing, BNF and Smalltalk, and getting your grammar, to be complete and correct. But then through performance profiling, identifying which of those production rules are actually really expensive if you just do it the brute force way, and optimizing them with inline Smalltalk code. But I think Epigram has a pretty nice way of doing that.
Have you done a talk on Epigram for us? I don't think you have before, have you?
Not for this group. I did one for California Smalltalkers.
Oh, okay. So that's probably there's a recording somewhere probably for that, but we can.
There's a recording, but it predates all my performance optimizations.
Oh,
so
okay.
It's definitely time to do another Epigram talk. Yeah.
Oh well, we'll bookmark that as a future point. This was sort of a slight teaser on that front.
Yeah.
Cool.
Is it available? Is it available on another source in the GitHub repo or something? Because the SPA page is broken.
Oh shit! Really?
It stops in it stops in the middle of downloading. It says it tries to connect from the Squeak.js to something. So if I try this in the browser, it doesn't work.
What's it doing? Oh, sorry, I'll fix that. What's going on? Oh, okay, it's running, but
then it stops. And if you open the, it comes up with a message not understood and with a connection issue.
Of course.
Okay, so it's most of the way there. Okay, sorry. Yeah, this image is actually pretty old. I'll fix it. Yeah, thanks for trying that.
Yeah, thanks.
Yeah.
But what is planned there? Do you want to release it somewhere only as a kind of image format, as part of the image, the epigram, or will you make it available on a GitHub somewhere so one can follow the progress, or would it be available with a liberal license or whatever?
Yeah, I want to work all that out. I imagine it will be an MIT licensed thing. And I haven't decided, how I want to make a file-friendly version of this yet. But yeah, that would be a good thing to have.
Do you work on it with tests? So do you test first and then write the code, or do you just write the code?
I started by just writing the code, but now there are tests. Yeah, so I mean, interop with GitHub has, there's a good culture that's grown up around that in the Pharaoh community, for example. So that's a closed problem, it seems like.
Yeah, you should be able to borrow the lessons learned from that, because it's had several runs at it to get it to a place where it's workable. So
yeah, I mean, I guess there were some things going on in the Gemstone community also around that, but it seems, my sense is that all of that seems to have converged.
I think so.
Let's see. Yeah.
Someone's just chipped in the background. I don't know if I didn't catch who it was, if they wanted to speak up again. Otherwise, I'll keep going through the chat. We're almost at the bottom of the chat.
Mm-hmm.
So someone says, would JIT pick work in STs translated to compiling inline WASM functions? From Steve. I guess he's talking about that final optimization bit after the stack interpreter.
Oh yeah, so one thing that another thing I like about the reification of instructions that Epigram's Smalltalk compiler does is that you can do things like peephole optimization at the instruction level by getting the instruction objects to do it. And I think something similar will be possible for WebAssembly components as well, for WebAssembly functions and instructions. So yeah, I'm imagining at the Smalltalk level, getting WASM functions and instructions to do optimizations at the Smalltalk level before they, render themselves as WebAssembly binary or WebAssembly text. Yeah, I think that could be really interesting.
Yeah. Some more good stuff from Torsten there.
Oh yeah. I sort of kind of hinted at this in the abstract. WASM is supported by the 3 most popular web browsers and by other host platforms as well. And that was sort of an oblique reference to at least WASI, W-A-S-I, and what Torsten mentions here. Yeah, you can run WebAssembly in all sorts of places. In fact, WebAssembly, the name is kind of a misnomer at this point. But again, it's a way of getting people initially interested by framing it as part of a familiar ecosystem. But it actually runs in all sorts of places.
Yeah, like on your CDN, like Cloudflare does it, doesn't it? I think.
Mm-hmm. Yeah.
Yeah. Kind of to iterate, JCell makes WASM hardware. Yeah, we'd like some of that. Okay. How does it handle errors in source? How does it handle errors in source code? Presumably, you wouldn't generate any errors if you're generating the source, but
yeah, but if you did, you'd be dead, or you just wouldn't instantiate.
Yeah.
But again, I think that spec is also in flux. What sort of error handling can you expect from the JavaScript API to WebAssembly? I don't think that's been thoroughly worked out yet, and it's probably going to evolve indefinitely. Yeah.
And then the last, you should be able to generate LR or LL parsers from your production rules.
True. Yep. Yeah, you can do whatever you want with this reified BNF.
And how well does Epigram identify errors in the source code it's parsing? Presumably you get error objects if you hit.
Oh yeah, quite well. Yeah, that's another thing that really kind of saved me when trying to do the SVG subset of XML. When there's something that a production rule doesn't like, it can raise an exception that tells you exactly which production rule is not happy and where in the source code it wasn't happy and what you should have said in the source file instead. Yeah, that's a really nice part of Epigram.
Yeah.
And in fact, when you get a debugger like that, it makes the context stack that you see in the debugger even prettier. The receivers in the contexts in the context stack, if they are if one of them is a production rule, it will print itself out, in a pretty way. It won't just say that it's a EBNF compound rule. It will actually tell you the name of the production rule you're dealing with, for example. So just by looking at the context stack of the middle of a parse, you can kind of get an idea for, where you are in the BNF tree. And that's pretty nice.
Yeah. Well, that wraps up all the questions on here. I don't know if anyone has any final thoughts. You've been going for quite a while, Craig. So, which is like amazing. It's impressive stuff.
Thanks, everyone.
Thanks again, Chris. Good to see you. Good to see everyone.
Yeah.
To track progress on this, Craig, is this going to be you'll do subsequent blog posts on it, or how's the best way to sort of watch
for sure
the unfolding story?
Looking forward for the next ones.
Yeah, definitely check out thiscontext.com. That's where future blog posts will detail all the gory details.
Awesome. I will. Thank you, guys. See you next time.
Yeah.
All right.
Bye.
Bye.
Save the chat just in case. I'll do that. There was a few good points in there. How do I type the name? Personal.
And I can hang out for a while.
Oh, I think it's just going to give it a name, is it? I think. Oh, I don't understand what it's doing. Maybe I press cancel. I thought I was saving the chat. Is that what file does? Screenshot, format, emoji. What do I do? Save chat. Oh, there we go.
Oh, I don't know. I'm always very paranoid about that. I just like select all and copy and paste it somewhere else.
Yeah, that's what I'm trying to do.
But I think it can give you a more nicely formatted file somehow.
There's this thing that says file in your computer, but it doesn't seem to let me type a file name, and it doesn't seem to let me understand what that's doing.
No, that's if you're going to upload a file.
Oh,
the save chat.
Ah.
Save chat is how you can.
Oh, and where does it save it to?
And
it saves it in the account.
Are you on a Mac or a Windows?
I'm on a Mac. Yeah.
So it'll save it. I think in the documents. There's a folder called Zoom in Documents, and it has it separate folders that it creates within that for each meeting that you go to.
Zoom. I see. Yes, you're right. Okay, yeah, there is something saved, and it has got today's date on it. Meeting saved chat. Okay, cool. All right, done that. Right. Cool. So we've got some of this stuff captured. So we'll see if we can surface it somehow, even if it's just comments on the actual meetup itself.
Wonderful. I appreciate it. Excellent talk, and thank you for the presentation.
Thank you. Thanks for coming.
Yes, very interesting. Thanks a lot.
So how far off do you think you are from just that final bit, Craig? Obviously, you've got other stuff that you're doing in parallel, but
oh, I think I'm just a day away from Hello WASM doing what I wanted it to do. I think BitBlit will probably take another week.
Oh, that quick?
Wow. It's the stack interpreter that I'm really looking forward to. I think that will take months. That will take months, probably the rest of the year. I mean, it's a spare time thing too, so that slows it down.
Yeah, but if you've got it up to that point, I mean, we're already cooking with gas at that level, aren't we? That sounds pretty cool.
Yeah, I mean, it's not even clear that a full interpreter or virtual machine would really be a daily driver anyway. Right. I just think it would be fun to do. It's the plugins that I really care about. Yeah.
So to what I was asking you at the beginning, so ultimately you've got the Squeak.js with WASM plugins, and you're just kind of diverting the right way where it makes sense. Otherwise, you're falling back on the Squeak.js stuff.
Yeah. And I also think it will be cool to bring in WASM modules that other people have written in other languages and use them from Squeak.js.
Oh yeah, of course, yeah. Because if you don't have that, then you're kind of limited to just what's in JavaScript, right? That's gotcha.
Yeah, because people are porting all sorts of amazing code bases to WebAssembly from other places.
Yeah, actually, so that is a good point. Actually, I think we sort of I missed that important piece actually. Yeah, if all the energy is in WebAssembly, then you want to be integrated into that so that you can actually call those useful things.
Yeah. Yeah. So, I mean, the mashups I've done so far just using JavaScript stuff has been amazing. I think it'll be even more amazing once it's just open season for all languages.
The slides that you generated through that, where is there a class that's just pumping that text to that plugin? Is that, got to ask you about that piece?
Oh yeah, Impress is really cool. In fact, if I'm opening up web pages, that's definitely one to do. It has a nice JS API, which I manipulate from Squeak. So it's funny. This site also just takes the form of an Impress slide deck, but if you actually look at the sources,
yeah.
It tells you everything you need to know. And yeah, it's very cute and very powerful. And sort of the one tweak, well, I made a bunch of tweaks to it for my uses here, but one of the most important ones is I made all of these things, editable. So you can actually edit the slides while you're showing them.
Right.
And you can also do whatever you would do from JavaScript, like reload the page,
yeah.
From a Squeak object or a Smalltalk object. And you can even add a new slide, between this one and the next one and start editing it.
Yeah.
And that's all, pretty easy to do because the Impress API is dirt simple. But it's actually using CSS to do all this 3D stuff, which is really fun.
Ah, yeah, it's neat. So have you just got a couple of wrapper classes on top, and then you can sort of send them a header and text and this kind of stuff, and then it kind of delegates down to the underlying Impress thing. Is that have I understood that correctly?
Yeah, exactly. It's all just DOM manipulation.
Right.
You make, in particular, you give it divs that have paragraphs in them. So this slide here, this is the div for that one. It's pretty simple.
Oh, I see. Okay. Oh, so you just create, you just manipulate the DOM, adding those things, and then Impress is then rendering it up. Is that the?
Yeah.
Ah, gotcha. Neat.
Yeah, that was maybe the first JS API I played with once I got my hands on Squeak.js. But then I've done a bunch of VR stuff, and there are all sorts of wild JS APIs out there.
So presumably, can you get callbacks from it? So if you wanted to inspect or evaluate something, is there you can do that, so you'll know the text, and then you can just kind of evaluate it in the context of caffeine or something.
Yeah, exactly. Yeah, and at the JS level, you can do anything with callbacks or JS promises that any other JavaScript code would do. And yeah, so it's pretty nice to be able to give a Smalltalk block closure as a callback to something in JavaScript.
Yeah. Oh, neat. So anyone else got any other questions, or do we call it an evening? What's the? Trying to see who else is on.
There are 10 of us left. Okay.
Yeah. Where is everyone?
Having lunch.
Yeah.
Sorry, I mean a meal.
That's what I'm looking for. View. Side by side. I suppose. I don't know if you want to stop sharing your screen, Craig, and we'll just put the people up and see. Are we just talking to us?